Okay, so in this problem, we can easily draw a picture like this and get the right answers, right? We can also do this with a matrix multiplication, so that's the question we posed. Now, one of the first matrices, matrix calculations, I just said row times column, right? One of the first rows times columns I saw was this. That turns out not to give the right answer, but at least we see how to multiply a row by a column, okay? Now, this is exactly what we did with 2 by 2 matrices, but some people still aren't quite clear on that rule, okay? Now, once we generalize it to, 4 numbers times 4 numbers, it's okay. Now, we got to have 4 numbers here if we've got 4 numbers here. We've got to have a number to match up with each one of these, because the rule is you multiply the first number times the first number, second number times the second number, third times the third, fourth times the fourth, and you add them. So the first thing you would have wanted to write out here is 0.05 times 10. That's this times this, right? Then second number times the second number, 0.1 times 10. And another 0.1 times 10, the third number, and then a 0.1 times 100. And then we write out each of these numbers, because this is going to help us see maybe what's wrong and why this doesn't work. And the calculation is correct. Don't skip to a calculator before you write out at least this step. Because if you skip to a calculator and do it all by punching buttons, you haven't written it out, you haven't seen this. You might see it on your calculator screen, but if you don't write it out, it's not going to reinforce what it means to multiply a row by a column, and many of you need that reinforcement right now. Okay? So when you first see something, don't get fancy with it. Don't skip because you're in a hurry, unless you really have to be in a hurry. Okay? But keep in mind, if you hurry and skip something, that you're likely to miss something important. Also, if you just immediately take a calculator in your hand to do something you've never done before, you really want to write it out to reinforce what it is you're doing, so you'll remember and adapt it to a new situation when the time comes. Okay, but anyhow, there it is. Now, that's not right. Clearly, this is not anything like what you would want to get. So actually, the problem I posed for you is kind of impossible to answer with a single row by a single column, okay? But I wanted to see what you would do. Now, what I want to do is, okay, we can't write this whole calculation as a single row by a single column, but what we can is write the calculation for the first number, that is, for the number of bugs in this tree. It's going to end up with 9.5, but don't just write down some matrix calculation that gives you 9.5. Write the one that corresponds to this system, and most specifically, we're going to use the whole column vector. 10, 10, 10, 100, the same way we did here. So we're going to have 4 numbers here to multiply these that are going to end up with this population of the first tree.
Oh, we got that.
Okay? And I think some of you might have gotten that one. Okay? But you were working on a problem that didn't really have a solution. And there's a reason I did that. Okay? To motivate what actually has to happen to get the whole solution, okay? So let's focus on the first tree, the row that you multiply by that population vector to give you the population on the first tree. And would work no matter what the population vector is here, right? It would apply to any population vector and would give you the population on the first tree.